Hello everyone. Today we will go through sinusoidal functions and look at how the graph behaves when we change certain parameters of the function. Before we dive into this, let us recap some terminology of periodic functions. A periodic function is a function which repeats itself over a certain interval. This interval is called a period of a function. Here we can see the graph of y is equal to sine x. In this graph, we can see that the x-axis is the midline, and that the graph has a peak at pi over 2 and 5 pi over 2, and a trough at negative pi over 2 and 3 pi over 2. Here we can see that the peak is the maximum possible x value in the y value in the function, and the trough is the minimum possible y value in the function. Based on this, we can define the period of a function as the distance between one peak to the next, or from one trough to the next. As you can see, the distance between the two peaks and the distance between the two troughs are both 2 pi, which shows that the period of this function is 2 pi. Now let's talk about the amplitude. The amplitude of a function is the height from the midline to the peak, or the midline to the trough. Or in other words, it is 1/2 the distance between the maximum and the minimum value of the function. In this graph, we can see that the distance between the midline and the peak is 1, and that the distance between the maximum value and the minimum value is 2, and the half of that is 1. So the amplitude is equal to 1. Now that we've understood the basic terminology, let us look at how the graph behaves when we change parameters of this function. Here we have the equation of a generic sine function, y is equal to a sine of bx plus c plus d. And here we have a and b equal to 1 and c and d equal to 0. Now let us see what happens when we change the values of each of these constants. Let's start with a. When we change the value of a to 2, we can see that the amplitude of this graph will become 2. And when we change the value of a to 3, we can see that the amplitude of this graph becomes 3. That means that the value of a in this function will always give you the value of the amplitude of the function. But what happens if a is 0? If a is 0, we can see that we just get a straight line. And if a is negative, we can see that the graph has been reflected across the x-axis. So this means that the value of a affects the amplitude of the function, and that a negative a will lead to a reflection across the x-axis. Now let's look at what b does. When I increase the value of b, we can see that the graph repeats more often, which means that its period decreases as the distance between its peak is reduced. And you can see that when I begin to decrease b from 0 to 1, you can see that the distance between the peaks increases, which shows that the period will increase. Now let's look at what c does. When I change the value of c, you can see that this graph undergoes a horizontal translation across the x-axis. This horizontal translation for these sinusoidal functions is called a phase shift. Now let's see how d affects the graph. As we change the value of d, you can see that this graph will undergo a vertical translation, which means that d controls the vertical position of the graph, or the midline of the graph. Now let's derive the equations for the phase shift and the period of a sinusoidal function. Over here we can see that we have a blue graph, which is y is equal to sine of x, and a red graph, which is y is equal to sine of bx plus c, which is the same thing as y equal to sine of x, but it's shifted through a horizontal translation. Here we can see that this value is the phase shift of this equation. In order to calculate the phase shift, let us observe the identical points on the two graphs. We can see that point A at point A, the value of the function is 0, and on the second graph, at point B, the value of the function is also 0. Let us find the value of x, where the second graph is 0. We know that the sine function is 0 when the value of the angle is 0. So, point B will occur when the angle bx plus c is equal to 0, and solving for x in this equation, we get that x is equal to negative c over b. And this is the equation for the phase shift of a sinusoidal curve. Now let's derive the period of the function y is equal to sine of bx plus c. Recall that the period of the function is the distance between the two maximum values or the two peaks, or the distance between two minimum values or troghs. Let me take the values of these two maxima, and let's say that they occur at x-coordinate x1 and x2. The period of this function will be the distance between the two, that is x2 minus x1. Now, in order to find this one, we can compare to the graph of y is equal to sine x. This means that sine of bx1 plus c has to equal to 1, and the sine of bx2 plus c should also equal to 1. This implies that bx1 plus c is equal to pi over 2, and bx2 plus c is equal to 5 pi over 2. Now, solving for x1 and x2 in the equations, in the first equation, we get that x1 is equal to 1 over b times pi over 2 minus c, and we get that x2 is equal to 1 over b times 5 pi over 2 minus c. Subtracting these two equations, we get that x2 minus x1 is equal to 2 pi over b, which is the formula for the period of a function. For any function in the form of sine of bx plus c, the period is going to be given by 2 pi over b. And also just recall that the cosine function is just a phase shift of the sine function, so you can use the same formula for that as well.